Right. My question number 23, they're saying in the diagram below, A, B, C, D is a parallelogram, as we can see that one. Then we are also told that diagonals of A, B, C, D, they intersect at M. So this is the intersection of the diagonals. F is a point on AD, such that AF is 2, FG is 4 is to 3. So which means we have AF it's 4, so our right in this case is 4K, FG is 3K. E is a point on AM such that EF is parallel to BD, as we can see. FC and MD, they intersect at G. You can see the point G there. Importantly, we know that it's a parallelogram. Right, then the first question is saying, calculate giving reasons the ratio of EM is to AM. So as we work it out, can you see that here we have EM is to AM. So as we do our solution, can you see that we are saying our EM over AM is equals to EM over AM is equals to, can you see we are going to make use of this triangle, and proportional division works because this is parallel to this. Actually, we can also even put that one here. So which means EM over AM is equals to, in this case, FG over AD. The reason being proportional division theorem, which is good. So straight away, which is equals to FD, we know that it will be 3K over AD. AD now becomes 7K. So which means it equals to 3 over 7. Good. Now we want to do CM over ME. CM over ME. Right. Can you see to it that we can even have, since because of proportional division theorem, we know that this is 3. So we can put it here as 3, probably 3H, and here I'll put it as 4H. So can you see to it that CM, let's find CM first. Can you see that CM is equals to 7H? The reason being that the diagonals they bisect. Diagonals bisect because it's a parallelogram. So which means AM equals to MC. The same applies BM equals to MD. Therefore, which therefore means in this case that CM over ME is equals to, we are saying CM is 7H. So let me write 7H. Yeah? Right. Then from there, CM over ME, CM is 7H over ME, which is 3H. Therefore, the answer becomes 7 over 3. Good. Then, still on number 23, I now have to find the area of triangle FDC over area of triangle BDC. So which means we are going to say equals to, look at the triangle FDC. Let me show you on the diagram triangle FDC. So can you see that one? One thing that we know about the area of a triangle is we can use the formula half base times height. So I'm going to make my height this line. It's perpendicular to this, which means it's also perpendicular to that. I'll call this the height to be H. So if I look at triangle FDC, my base is this one. So which means the area now working out, it now becomes half my base. Let me take the camera. My base is FD and the height is H, which is there. So which means it will be half, which is FD multiplied by height, which is H, all over. Now area of triangle BDC. Let's go to the diagram. BDC. So I will still use BC as my base, which therefore means here it will be equals to half of the base is BC. As you can see there, the base is BC multiplied by the height is still the same, which is H, which means here it will be now equals to half cancels with half, H cancels with H, which means it will be FD over BC, which is now equals to, showing again on the diagram, can you see FD is 3K, and can you see BC parallel from a parallelogram, opposite sides are parallel and they are also equal, which means from here to there it's 7K, which means BC is also equals to 7K. So coming there, and we are saying FD is 3K. So working it out, we are therefore saying it now becomes 3K over 7K, which is equals to 3 over 7. Good. I also want us to do another method. Remember here we want to find the area of triangle FDC over area of triangle BDC. That's what we are looking for. Let me take my work much closer there, and also the diagram. Yes, I'm sure you can see. Right, I want us to use the other formula for the area of a triangle. This is the first one. You can also use A equals to half of AB multiplied by sine of angle C. That is, you say half of two sides, half of the product of two sides, F. In this case, we can say FD times DC multiplied by sine of the included angle, which is this angle here. So since I'm also considering angle BDC, I can alert this angle here to be theta. So which means that angle becomes theta. If this angle becomes theta, it therefore this angle also becomes 180 minus theta. This is because these are co-interior angles, right? Therefore, which now means in this case, as we do our work, it now becomes a half of FD multiplied by DC multiplied by sine of the included angle, which will be sine of 180 minus theta, all over, in this case, it will be half of triangle BDC. So which means it will be half of BC multiplied by DC multiplied by sine of angle theta. I'm sure you can see that one, which is now equals to, can you see half cancels with the half, DC cancels with DC, therefore I'll be left with the FD multiplied by sine 180 minus theta. 180 minus theta is in quadrant number 2, and sine is positive in that quadrant, which means this becomes sine theta all over BC sine theta again which is equals to, can you see that sine theta cancels? Then I'm left with FD over BC, which is equals to my FD you can see is 3K, so it will be 3K over BC, which is BC you can see there, which is 7K, which is equals to 3 over 7. Good. Thank you so much. God bless you.